Yeah, so let's consider this same case where the boat is supposed to cross the river with zero drift. Okay. Let's say speed of boat in still water is some 20 meters per second. Okay. Let's say the boat has an engine, like it is propelled by an engine. So on water, it goes with a speed of 20 meters per second. And river flow, let's assume the speed is okay 15 meters per second. 15, or let's take 12. And width of the river, let it be some 800 meters. 800 meters possible. Yeah. Yeah. So this is the situation. You have to find out first the angle theta such that the boat crosses the river with zero drift. Next, time taken to cross the river. Okay. The angle theta and the time taken by the boat to cross the river. Try this, all of you. Velocity of boat in still, speed of boat in still water means velocity of boat with respect to water. Okay. Or sorry, speed of boat with respect to water. That is 20. And you know the angle has to be slightly upstream like this, okay, as shown in the diagram. Actually, in the question, they won't give you the diagram. You'll have to visualize it this way. And velocity of water is say 12 meters per second. Try this, all of you. You can give your answers in chat. Okay, I got one answer as okay, angle and time. Fine. Vanilla, your answer is correct only. Use of any answer? Aishwarya, what about you? Okay, listen, all of you. We want the boat to cross the river with zero drift. Means effectively means even after being dragged by water, okay, the boat should move in the y direction. Fine. For that to happen, we know it should be, it should try to move at an angle upstream like this. Let the angle be theta with the y-axis. See, had there been no flow, the boat would have gone like this. But because of the flow, it gets dragged downstream. Every instant it gets dragged downstream. It's not like it goes to that point and then starts moving downstream. That is not how it happens. At every moment, if you visualize the vector diagram, this is how the boat is angled. So with respect to water surface, that is how the boat tries to move. Okay, that is how it moves, not tries to move. With respect to water, it moves like that. Now we know VBW is VB, velocity of boat, minus VW, velocity of water. So the effective velocity of the boat will be velocity of boat with respect to water plus the velocity of water. Okay. Now velocity of boat with respect to water is this way. Velocity of water is downstream like this. You have to add these two. Okay, you have to add these two to get the effective velocity of the boat. Therefore, the effective velocity of the boat will be like this. This is the effective velocity of the boat, and this is what we are looking for. Fine. This angle is what we are looking for. You just have to find out the angle at which VBW must be inclined such that VBW plus VW is in the y direction. So this is the vector diagram for zero drift. You can solve questions this way also. Okay, let's do it. Now speed of boat in still water we know is 20. So VBW is 20. Speed of water we know is 12. That's all. You know two sides of this triangle and you need the angle. You can easily tell it's a right angle triangle. Okay, because VW is along the x-axis. VB, ultimately we want the boat to move in the y direction to go with zero drift. So this is a right angle triangle and you know two sides of it, it's easy to tell the angle. So for theta, we know the opposite side is 12 and the hypotenuse is 20. Opposite hypotenuse are related by sine theta. So we can say sine theta is equal to 12 divided by 20. That is 3 divided by 5. And we know that sine 37 degrees is 3 by 5. So we can say the angle is 37 degrees. Okay. Is this approach clear to all of you? How we solved this? We want the effective velocity of the boat to be in the y direction. And you had to find out the angle that VBW must make with the y-axis. There's another way also to solve. Let's say for zero drift, VBW must be pointed at an angle theta like this. That theta is what we are trying to find out. VBW is 20 units, we know that. Get its x component. Its x component and its y component also. The y component will be 20 cos theta. The x component to the left will be 20 sine theta. So we should take it as minus 20 sine theta I cap. Y component is 20 cos theta j cap. That is velocity of boat relative to water. And we know the velocity of water is 12 I cap. Okay, all of them are in meters per second. Now you can write velocity of boat, effective velocity of boat. Velocity of boat with respect to water plus the velocity of water. Now boat with respect to water, if you write it as a vector, it will become minus 20 sine theta I cap plus 20 cos theta j cap. That is velocity of boat with respect to water plus the velocity of water is 12 I cap. Add these two. If you write it as a single vector, it becomes 12 minus 20 sine theta I cap plus 20 cos theta j cap. Therefore, effectively, this is the x component of the boat's velocity and this is the y component of the boat's velocity. Now we want the boat to cross with zero drift, means it should not have any x component. It should not get displaced along the flow of the river. It should only move perpendicular to the flow of the river. Okay. So if you equate this to zero, equating the x component to zero means 12 is equal to 20 sine theta. You get the same thing. Sine theta is 12 by 20, 3 by 5. So theta becomes 37 degrees. So without using the vector diagram, you can solve it like this. So is this clear to all of you? Will you be able to solve for this angle theta if some other velocities are given? If any of you have any doubt or you want me to repeat, you can ask. Saket, did you understand?
Yes, sir.
Okay. Fine. So that's the angle at which the boat must be inclined to cross the river with zero drift. And see, again, don't remember the formula. Fine. Don't remember it like V sine theta should be equal to U or anything like that. Here I wrote it as V sine theta, the x component of VBW, and don't blindly equate it to speed of water, because in this diagram, theta is with the y-axis. Now in some other question, they may ask you to calculate the angle with the x-axis. They may ask you, what is the angle with the river bank at which the boat must be directed? If that angle is alpha, then this component of velocity becomes V cos alpha this time, because angle alpha is with this direction. Okay, so you have to read properly from the question which angle they are referring to, whether they want angle with the perpendicular direction or they want angle with the upstream direction, that is alpha. Sometimes they may even ask you what is the angle with the downstream direction at which the boat must be pointed to cross with zero drift. Okay, how will you calculate that? Get alpha and you can write this as 180 degree minus alpha, or you can get theta and you can write it as 90 degree plus theta. They're both the same. Okay, writing directly in terms of this angle that I have shown in orange will be difficult, slightly confusing. So it's better to take one of those angles, calculate them, and then express this angle with the downstream direction. So yeah, no point remembering the formula, remember the idea. What is the idea? To cross with zero drift, the boat must be directed at an angle like this, such that the x component of velocity of boat with respect to river, VBW, the x component of VBW cancels the velocity of river flow. Okay. And the y component takes it across the river to the other side. Okay. The next thing you are asked to calculate is the time taken to cross the river. Can any of you tell me an idea? Vanilla, don't tell. Others, anyone? How will you calculate the time taken to cross the river?
Sir, by using y components.
Yeah, it is the y component of velocity which helps the boat cross the river. Now in the y direction, to cross the river, the displacement in y direction is 800 meters. And the y component of velocity we can easily find out now. 20 cos theta, right? That was the y component of velocity. So Vy is 20 cos. We calculated theta as 37 degrees. That becomes 16 meters per second. The cos 37 is 4 by 5. So the y component of velocity is 16. That 16 is what helps it cross the river. And displacement in y direction is 800 meters. We know displacement in y direction is velocity in y direction multiplied with the time, since there's no acceleration. So 16 into t becomes 50 seconds. 800 by 16, it takes 50 seconds to cross the river. Hope this is clear to all of you. If you have any doubts, you can ask. Okay. So listen, irrespective of whether the boat is crossing with zero drift or not, let's just consider this diagram. Suppose the boat is directed at some angle, some random angle. with the y-axis. Velocity of boat with respect to water. See, whatever is the direction in which the boat is pointing, that is the direction in which it moves on the surface of water. Okay, means had the water been stationary, it would have gone in that direction. So let's say this angle is some theta. With the y-axis, it makes an angle theta. And let's say velocity of water is this way, VW. So we can write velocity of boat with respect to water. You can express it in terms of I cap, J cap. It becomes the y component will be VBW cos theta, because theta is with the y-axis. And the x component will be VBW sin theta. But it's to the left. So you write it as minus VBW sin theta I cap plus VBW cos theta J cap. That's the velocity of boat relative to water. And velocity of water is VW I cap. From these two, we can tell that the effective velocity of the boat, it is VBW plus VW, right? Add these two, it becomes VW minus VBW sin theta I cap plus VBW cos theta J cap. Okay, so this will be the ultimate velocity with which the boat moves. Now tell me, which is the component which helps the boat cross the river? Which component helps the boat cross the river?
Y component.
Y component, VBW cos theta. Okay, this is the Y component. That is what helps it cross the river. This component is the X component. It makes the boat get displaced along the river, along the flow of the river. It may be zero, it may be positive, it may be negative. Okay. Now see, suppose the river has some width. Let's call the width as W. Okay. Width W is given to you, and we know that the Y component of velocity is this much. Then generally, how will you write the expression for time taken to cross the river? Anyone?
Sir, width by velocity of Y component.
Okay, Pawan, can you repeat what you said?
Sir, width by velocity of Y component.
Correct. Why is only Pawan giving? What are the others doing? I asked you time taken to cross the river. Okay. See, we know X component of velocity, we know Y component of velocity also. But we know displacement only in the Y direction. Width becomes displacement in the Y direction. The boat may go like this, may cross with zero drift, may go like this or like this or like this. Okay, depends on the angle at which it is oriented, and it depends on its speed also. But what helps it cross the river is the Y component, and irrespective of the path along which it crosses the river, the Y component of displacement is always the width itself. Okay, for all these displacements, whether it is this, or this, the Y component is the width itself, and that is what you will make use of to calculate the time taken to cross the river. So time taken to cross will be displacement in Y direction divided by the Y component of velocity. So it becomes W divided by VBW cos theta, where W is the width of the river, VBW is the speed of boat relative to still water. Okay. Now let's imagine this theta is variable. Okay, let's say you can choose theta. I mean, you can choose the angle at which the boat is driven. The question is, what angle theta will you choose? Or at what angle should the boat be directed such that it takes the minimum time to cross? Type your answers in chat, don't unmute. To cross the river in least possible time. How much should theta be? That is the question. All other things are fixed. What are the other things? Speed of water is fixed. Speed of boat with respect to water is fixed. And width of the river is also fixed. Theta is the only thing that is adjustable or variable. So what angle theta should be chosen to cross the river in least possible time or the shortest possible time? The hint is in this formula. Think about it and answer, all of you. I got only one answer till now. Okay, two answers. Saket, Pawan, your answers are correct. Aishwarya, can you unmute? We'll discuss.
Yes, sir.
You were asked to find out the theta for which time taken to cross would be minimum. So you'll have to find out theta such that this term is minimum. Okay. There are three terms in this: width of the river, speed of boat with respect to water, and then theta. Which of them is variable?
Theta.
Theta. So you have to find out the theta value which makes this whole thing, this fraction, minimum. Generally, when will okay, wait, the theta term is in the denominator. To minimize the fraction, should denominator be maximized or minimized? If you want the whole thing to be minimum, should the denominator be at its maximum value or its minimum value?
At the maximum value.
The larger the denominator, smaller the value of the fraction. We know that. So if you want to minimize this entire thing, what you should do is you should maximize cos theta. Aishwarya, tell me, when is cos theta maximum? Means for what angle theta is cos theta maximum?
0 degree.
That's all. Correct. Theta should be 0 degrees. Okay. Theta being 0 degrees means the boat should be directed perpendicular to the flow of the river. So it should not be inclined at an angle like this to cross the river in the shortest possible time. Just a moment. Yeah, the boat must be angled this way, perpendicular to the flow of the river, or perpendicular to the river bank also, you can say. Why? Because see, ultimately the velocity with which the boat moves is velocity of boat with respect to water plus the velocity of water. Now we know velocity of water is only in the x direction. Velocity of water doesn't have a y component. So the flow of the river cannot help the boat cross the river. Okay. The only thing which can help the boat cross the river is the y component of this VBW. Because VW doesn't have a y component at all. Velocity of water is this way. Velocity of boat relative to water, depending on the orientation of the boat, it can have a y component. And that is what helps it cross the river. Now we want to cross the river in the shortest possible time. To cross river in shortest possible time, generally when you want to cover a distance in a shortest possible time, you have to give maximum speed in that direction. Okay. So see, it's the y component of VBW which helps the boat cross the river. And you want to cross in shortest possible time. So you have to ensure that the y component of VBW is maximum. And how do you do that? Make VBW point in the y direction. That's all. In that way, all the VBW is in the y direction itself. That is the best possible y component you can get. Okay. Because if it is inclined at some other angle, maybe downstream like this or upstream like this, you can see its component will become shorter. Okay, I'll draw it as a dotted arrow. The components will be shorter. If you want to cross the river in shortest possible time, you have to ensure that this component is maximum. So make all the VBW point in that direction itself. And that is what the mathematics also say here. We derived a general expression for time taken to cross the river. And to minimize the time taken to cross the river, we see that theta should be 0 degrees. Okay. So usually these are the two cases they'll be interested in: how to cross the river with zero drift. In that case, at what angle the boat should be pointed, how much time it will take to cross the river. And the other thing they'll be interested in is how to cross the river in the shortest possible time. Shortest possible time means VBW should be directed this way. Now, VBW is directed like this, but we know the river is flowing. So effectively what happens is the boat moves at an angle like this. It doesn't travel in a straight line. Okay. So zero drift case is not the case for shortest possible time to cross the river. Because if you are trying to cross with zero drift, I'll show you that also. In this case, since the boat is directed along the y-axis, it will suffer some drift. Okay. And ultimately it will end up going like this. This is the case where the boat crosses with where the boat crosses in the shortest possible time. Now the zero drift case, if you see, the boat must be oriented this way to go with zero drift. In that zero drift case, all the VBW is not in the y direction. Only one component of it, VBW cos theta, will be in the y direction. So it will take more time to cross the river that way. Because some of its velocity is being used up. One component, the x component of its velocity, is being used up to cancel the water's velocity. Only the remaining component can help it cross the river. So it will take more time. So zero drift case is not the case where the boat crosses in the shortest possible time. To cross in the shortest possible time, the boat must be directed perpendicular to the river. And in that case, it will suffer some drift. Okay, let's solve one last question based on this. Then we will move on to circular motion. Or, okay, I'll not give you the diagram this time. You have to visualize. Speed of boat in still water is, let's say, 20 meters per second. Speed of water flow is 10 meters per second. The boat is directed at an angle of 37 degrees with the downstream direction. Boat is directed at an angle 37 degrees with the downstream direction. First, calculate time taken to cross the river. Okay, I have to give you the width of the river, no? Take the width of the river as 600 meters, or okay, fine, take it as 600 meters, not an issue. Calculate the time taken to cross the river and calculate the actual distance moved by the boat. Visualize the situation, all of you. Draw the rough diagram of a river. Just draw the banks, draw the boat. Okay, just draw something like this. Inclined at an angle 37 degrees with the downstream direction. Draw the VBW vector, then write them as components and start solving the problem. I got only one answer so far. That too. Okay, that is correct only. That too only for time taken to cross. But what is happening? Why is it taking so long? Aishwarya, how are you trying to solve?
Sir,
How are you trying to solve? Or where are you stuck?
sir, no, it's just that I couldn't access the chat option, so I did not send the
Okay.
message.
What is your answer for time taken to cross the river?
50 seconds.
Okay, fine, fine. Saket, what about you? What is your answer? Or are you stuck somewhere?
Sir, I actually got 1,000 seconds. Sir.
How are you trying to solve this?
Sir, judged by VW sign, sorry, VBW sign 37 for the
No.
time taken. Sir.
For time taken, you want to use VBW sine 37. Correct only. But how will that become 1000?
Sir, and for B, I got 6 I cap plus 8 J caps.
Wait, we'll discuss step by step. So let us visualize the situation first, all of you. So the boat is directed at 37 degrees with downstream direction. Let's say the river is flowing this way to the right. Then that itself becomes the downstream direction. With that, the boat has to be directed at 37 degrees. So it will look somewhat like this. Yeah. I'll assume it's starting from somewhere here. So the boat is pointing in this direction. So the direction in which the boat points is the direction of VBW. That is the velocity of boat relative to water. That may not be the actual velocity in which the boat moves. Fine. How to get the actual velocity? Actual velocity or the effective velocity with which the boat moves is velocity of boat relative to water plus the velocity of water. So you have to add this VBW vector and VW vector. I'll copy paste this. So adding VBW and VW, this is the effective velocity with which the boat moves, or that is the effective, you can say the direction and speed with which the boat moves. It goes like this. It's trying to go at this angle, but the water will make it, the water will give it some extra velocity in this direction. Effectively, the boat ends up going like this. Okay. Now let us do the mathematical part. VBW is this vector. VW is this vector. Effective velocity of boat is this vector, VB. Okay. VBW's magnitude, speed of boat relative to still water, is 20 meters per second. So VBW's magnitude is 20. And it is given in the question that it makes an angle 37 degrees with the x-axis, with the downstream direction. Downstream is the flow direction. Okay, direction of the flow. It makes 37 degrees. Then Yusuf, can you unmute? Okay. Nishita?
Yes, sir.
Can you tell that vector VBW in terms of its components? Its magnitude is 20 and it makes 37 degrees with the x-axis. Tell me the x and y components of that vector. Magnitude 20, angle with x-axis is 37 degrees. So how do you calculate the component? Okay, fine. Saket, tell me the components.
Sir, for in the x direction, it is going to be VW cos theta, sir.
VBW cos theta. See, generally, any vector whose magnitude is V and makes an angle theta with some direction, if you want component in that direction, it will simply be magnitude V multiplied with cos theta. Okay. So here, angle with x-axis is 37. So the x component will be 20 cos 37 degrees. And that will be to the right. So positive I cap. And the y component with x-axis, if it makes 37 degrees, with y-axis, it will be making 53 degrees. Then the y component will be 20 cos 53 degrees. And it will be upward, so j cap. Therefore, this becomes 16 I cap plus 12 j cap meters per second. That's the velocity of boat relative to water. Okay, Nishita, is this clear?
Yes, sir.
Now, can you tell velocity of water as a vector? Its magnitude is, we have taken it as 10. You can see its direction. Its direction is towards right. How do you express it as a vector? 10 units directed to the right. Like in terms of I cap, j cap, how do you write it?
10 I cap, sir.
Simply 10 I cap. Correct. That's all. So we got VBW and VW as vectors mathematically. Then we will be able to express VB as a vector. VBW plus VW, add them. 16 plus 10, 26 I cap plus 12 j cap. That's the effective velocity with which the boat crosses the river. That is that red vector that I have drawn. Okay. And you can clearly see the x component of the boat's velocity and the y component of the boat's velocity. This is what helps in crossing the river. So if you want to calculate time taken to cross the river now, it will be displacement in y direction divided by velocity component in the y direction. Displacement in y direction is the width of the river. Width of the river was given in the problem as 600 meters. That's all. 600 divided by y component 12 becomes 50 seconds. Okay. The next thing you are asked to calculate is the actual distance moved by the boat while crossing the river. The actual distance moved by the boat will be this. All the way from, let's call this starting point as A to this finishing point B. That actual distance is what we want. Can any of you tell me an idea to calculate the distance? We know the width, and now we found out the effective velocity. We even found out the time taken to cross the river. There are many ideas that can be used to calculate this distance. Can you tell one of them? If you know velocity and time, can't you tell the distance? Anyone? Okay. How is displacement related to velocity and time? Let's get this displacement first. Anyone?
Velocity by time, sir.
Velocity multiplied with time. Okay. Right. So that total displacement can be written as effective velocity of the boat multiplied with the time. Time taken to cross, we found out 50 seconds. Right? Effective velocity of the boat is 26 I cap plus 12 j cap. Multiply that with 50. This is the total displacement that it undergoes as it crosses the river. Is this clear to all of you? Are you all convinced with this or not? To calculate that displacement, I did effective velocity into time. Do any of you have any doubt in that? Okay. During that displacement, did the boat change its direction? Did the boat ever change its direction? Answer me yes or no.
No, sir.
Clearly not. Anything which moves with a constant velocity never changes direction. Okay, the boat moved with a constant velocity all the way from A to B, so it's a straight line. It did not change direction. It may not look like a straight line. I drew it with free hand, but it's moving along a straight line. And when there is no direction change, one of you tell me, how is distance related to displacement? When an object moves without ever changing its direction, how is distance covered by the object related to its displacement?
Distance is equal to magnitude of displacement.
Correct. Distance is equal to magnitude of displacement. So the actual distance covered by the boat will be the magnitude of this vector. Okay. You can write this vector as 13 I cap plus 6 j cap multiplied with 100. And when taking magnitude, you can put the 100 aside and take square root of 13 square plus 6 square. Simplification you can do later, but this is the total distance. We did this using velocity and time. Okay, since we calculated time already, we followed this procedure. There is another way also to solve. Can any of you tell me what is the other way without using time? How to tell the total displacement or the total distance covered by the boat while crossing the river? Pawan, last class you told me an idea to calculate drift. Do you remember? I was explaining in terms of x component of velocity and time, but you said we can do it without using time. What was the idea you shared?
Sir, drift, sir.
How to calculate drift without time? The idea you gave there was to use this angle theta. Using this angle and the width. Okay, if you know the width and this angle, since this is a right angle triangle, you said we could calculate this drift. Okay. We can do something similar in this case also. How? We know the width of the river, 600 meters. 600 only, no? Yeah. We know that the width of the river is 600 meters. Just a moment. Okay. And we derived the VB vector. Now I'll erase the other vectors just to make the situation clear. We derived the VB vector. We know its x component 26 I cap. We know its y component 12 j cap. Okay. So VB vector is like this, 26 I cap, 12 j cap. So indirectly we know this angle. Let's call this angle alpha. Using that angle alpha and this right angle triangle that you now see on the screen, you can tell this displacement. How? First of all, from that vector, we can say tan alpha is opposite by adjacent, 12 by 26. So indirectly alpha is known to us. And I think 2 or 3 classes back, I told you all, if you know tan alpha as A by B, you can derive sin alpha and cos alpha from it. Can one of you tell me what is the formula for sin alpha? If tan alpha is A by B, how much is sin alpha?
A by root A square plus B square, sir.
Correct. A by root A square plus B square. And you can even derive cos alpha. Cos alpha will be B by root A square plus B square. Right. So if tan is known, sin and cos are known. Now see, to this angle alpha, in the bigger right angle triangle now, 600 is the opposite side. And the distance S that we are trying to calculate is the hypotenuse. And sin alpha relates opposite to hypotenuse. So sin alpha is equal to 600 divided by the distance that we want. This way you can solve without using time. Okay, so first from tan alpha you get sin alpha and equate it to 600 divided by S. But see, it's all based on visualization. And also Don't worry if you are not getting ideas to solve these problems. You need a little more practice. And as the course progresses, you all are studying in your colleges and all, also schools and colleges. As you solve problems, more and more problems, you will start seeing these things very easily. Okay. This visualization and all will become easy for you in due course. But if you want to do well in this topic right now, you will have to practice more. Okay. So in this question, you are given some random situation. River was flowing with a particular speed, boat was directed some way. Okay. They didn't ask you whether it crosses with zero drift and all. For that direction in which the boat is pointed, they just asked you how much time it takes to cross the river and where does it go, or how much distance does it actually travel by the time it crosses the river. You can do it. Find out the absolute velocity of the boat, the effective velocity of the boat, and using its components, you find out the time taken to cross. And using the angle made by it, you can tell the actual distance covered by it. Okay, so you are making use of some mathematics to answer these questions. Okay, so I had sent one worksheet in which there were questions related to rain, relative velocity of rain and all. Tomorrow you'll get one worksheet based on these questions, river boat questions. See, make some effort and solve those questions. First, you should revise the notes. What were the situations that we discussed in class? How did we approach the problem? Like, suppose the boat was pointed in a particular direction. How did we write its velocity? How did we find out the time taken to cross? How did we calculate the drift? Observe that. Go through the notes. See, many teachers tell this, you revise the notes, then solve problems. And many students revise the notes also. But what they do while revising the notes is they just read through the notes. That is not enough. That is not going to help you in JEE or NEET preparation. Okay. For JEE or NEET preparation, revision of notes means recollecting every idea that was discussed in the class. It's a time-taking process. It's not like reading through those 1-2 pages and then solving problems. Okay. This preparation itself is a time-taking process. It requires a lot of effort also. So for some half an hour or so, you recollect all these ideas. How we wrote the VBW as a vector, how we write VW as a vector, combining them, how we get the velocity of the boat, effective velocity of the boat, then how we make use of that to calculate drift, time taken to cross and such things, total distance. Revise the notes first, recollect all the ideas that were discussed, then you attempt problems, it will be easy. Not just the problems that I am giving, whatever your other teachers are teaching, or whenever you want to practice any questions, recollect the ideas related to that concept, then start solving the problems. It will be an easy process. Okay. The next concept we have to discuss, the last part of this chapter, is circular motion. Okay, uniform circular motion. We'll just discuss some basics about it. Can one of you give me any example, any real life example of an object moving in a circle? Where do we see circular motion in daily life?
Earth's rotation.
Earth's rotation, how can you say it is circular?
Okay, maybe fans.
Fan also, is the whole fan undergoing circular motion, or are individual particles of the fan undergoing circular motion?
Individual particles.
Okay, that is what I was expecting when I asked you, how do you say Earth's rotation is circular motion? Earth's rotation as a whole, you can't call it as circular motion. It's spinning. Earth is spinning around its own axis. But any one point on the surface of Earth, if you see, it will be going around in a circle around the axis. Had you said Earth's revolution around the sun, it would have been more reasonable. Actually, Earth's revolution around the sun happens in an elliptical path. It's not exactly a circle, but it's roughly, almost a circle. Okay. So yeah, any other examples, anyone? Where do we see circular motion in daily life? Actually, Earth rotation we cannot feel. We know it happens, but we cannot feel it.
For minute hand on the clock.
What did he say? Okay, the minutes hand of a clock. Correct. Again, any 1 point or a particle on a minute's hand of a clock, if you take, it will move in a circle. Correct. Okay, so there are many cases where objects move in a circle, and they need not move in a complete circle also, even if they follow a curved path. Okay, for every curved path, we can define something called a radius of curvature. What do we mean by that? Suppose there's a curved path like this. Clearly, this cannot be part of a circle. Okay, but if you consider a part of it, let's say from here to here, there is a certain way in which it curves. Okay, and if you follow that way in which it curves, you can make a circle out of it. I mean, you can visualize it to be part of a circle. Just a moment. So just continue with this radius. You can form a circle with that radius. Okay, I won't draw the complete circle. Of course, I cannot draw a circle with free hand, but you can visualize a circle somewhat like this. So that part of the path is part of this circle. Again, here, you can take another part of the path here. Here, it's almost straight. So if you want to make this a part of a circle, that circle will have to be huge. Maybe somewhat like this. Again, I'm not drawing the whole circle. You can visualize that part as part of a circular path like this. So what we are going to discuss now is applicable generally to motion in a curved path in 2 dimensions. Fine. It need not actually move in a complete circle. We'll take examples where object moves in a complete circle, but the ideas can be applied to simple curved motion also. Okay. Let's assume there's an object moving along a circle like this. Let's say the object is initially somewhere here. And okay, let's take this as its initial position A. And moving from A, let's say it is moving anti-clockwise. Like this. After some time, you imagine it reaches some position B here and continues. Okay. You can imagine it continuing to move along the circle, not an issue. Like a runner running around a circular track. So tell me, first thing, in circular motion, we'll discuss what is uniform circular motion. We still didn't come to that point. But in circular motion, as the object moves along this curved path, can velocity of the object be constant? Is it possible for an object to move along a circular path with its velocity being constant? Any answer, anyone? You can think in reverse. If the velocity of an object is constant, how should it move? Then you can answer this question.
Sir, no.
Pawan, why?
సార్ యూనిఫామ్ కి వెళ్ళాలంటే పాత్ స్ట్రైట్ గా ఉండాలి.
Can you repeat what you said? Uniform?
సార్ ఒక పార్ట్ కి వెళ్ళాలని యూనిఫామ్ వెలాసిటీతో వెళ్ళాలంటే అంటే పాత్ స్ట్రైట్ లైన్ ఉండాలి.
Okay. So yeah, that reverse thinking. If the velocity of an object is constant, it moves in a straight line. Because velocity includes magnitude as well as direction. No? If velocity is constant, means direction is fixed. Then how can the object turn like this? Fine. So for circular motion, velocity cannot be constant. The answer is no. Because direction of motion of the object has to keep changing. For example, at this moment, okay, at its initial position, the object is moving in this direction. Its velocity is directed that way. At that position B, its velocity is directed this way. Okay. At some other position, if you see, okay, call this as position C if you want, its velocity would be directed this way. Not just in this case, in any case, the direction of motion of an object is tangential to the path at that instant. Okay, at that position. So clearly the direction has to keep changing. Therefore, velocity cannot be constant because velocity by default includes direction. By definition, velocity includes direction. That cannot be constant. Okay. Now answer this, all of you. In circular motion, or for an object to move or undergo circular motion, is acceleration necessary? Should the object accelerate?
Yes, sir.
Okay. How do you justify that?
Sir, అంటే కాన్స్టెంట్ వెలాసిటీ లేదంటే వెలాసిటీ చేంజ్ అవుతుంది.
Okay, okay, reasonable. We know that velocity has to change, and velocity changes if there is acceleration, if and only if. Means if velocity changes, there is acceleration. Reverse, if acceleration is there, velocity must change. Here we know velocity cannot be constant. Direction should keep changing, no? That can happen only if there is acceleration. Okay, so the answer is acceleration necessary. The answer is yes. Okay, next. Few days back, we discussed something about tangential acceleration and radial acceleration. Okay, let me quickly recollect that for you. Suppose an object is moving in this direction, its velocity will be this way. And let's say its acceleration is in this direction. You can resolve acceleration into two components. One component of acceleration parallel to velocity, that is called tangential acceleration. And another component of acceleration perpendicular to velocity, it's called radial acceleration. Okay. Can one of you quickly tell me what does tangential acceleration do to an object? We had discussed this before also. Acceleration along the velocity, along the direction of velocity, what does it do to an object? We had discussed this in the beginning of projectile motion in a plane also. We resolved gravity into two components, one along the line of velocity, one perpendicular to velocity. What does acceleration along the line of velocity do to the object? Okay, or you forget all that. It's understood that you forgot all that. Tell me this. Suppose velocity is to the right and acceleration is also to the right. What happens to an object like this?
It moves faster, sir.
In the same direction, it moves faster, means its speed changes. Okay. So tangential acceleration changes the speed of an object. It cannot make it go on a curved path. Okay, it only changes the speed. Okay, what does radial acceleration do? If an object is moving like this, okay, some ball or something, coin, ball, let's say it is moving this way, and you apply a force in this direction.
So change in direction.
It changes the direction, it deviates from its path. Radial acceleration changes direction of motion. Fine. Remember this is a very important idea, and we had discussed this before also, I think, in projectile motion. The beginning of projectile motion, maybe in this lecture or the previous one, we resolved gravity into two components. Okay, gravity, which is vertically downward, you can split it into one component along the line of velocity and one component perpendicular to line of velocity. The component along the line of velocity, this one, changes the speed of the projectile. Okay, you can see it is opposite to initial velocity. That's why speed will decrease during ascent. It slows down during ascent. We had discussed this. And the other component that is there, perpendicular to velocity, this one, it changes the direction. That is what makes it follow that curved path. Okay, anyway, let's continue. Now this, we are discussing the motion of an object along a circle. So tell me, now we have decided that acceleration is necessary because velocity is changing. Now tell me, is radial acceleration necessary? For an object to move in a circle?
Yes, sir.
Definitely, the direction of motion has to change. So radial acceleration is compulsory. The answer is yes. Next question. Is tangential acceleration necessary?
So no, sir.
Okay, Yusuf, how do you justify that?
So we're studying uniform circular motions. We don't need to change the speed again and again.
Okay, so you know what is uniform circular motion. Fine, fine. Now see, tangential acceleration changes the speed of motion. Now, while moving in a circle, direction change is compulsory. That cannot be avoided. But speed may or may not change. Okay. For example, you take Earth's rotation itself. Consider a point on the Earth's surface rotating around its axis. We know the Earth always takes 24 hours to complete one rotation, close to 24 hours, but it takes the same time to complete one rotation. So you can say that it is moving, that particle is moving in with constant speed. Its direction keeps changing like this, but the speed is constant. Fine. But it's not compulsory that the speed is constant. You imagine a person running along a circular track. It's not necessary that the person always runs with the same speed. Okay, he may stop in between, he may speed up, slow down. So for circular motion, speed may change, but direction has to change. Direction has to change, so radial acceleration is compulsory. Speed may change, so tangential acceleration is not compulsory. Okay. So we can mention here, like, if speed varies, then there is tangential acceleration. Otherwise, no tangential acceleration. Okay. And now the heading that we wrote, uniform circular motion, as Yusuf was saying, we call circular motion as uniform circular motion if the speed is constant. Fine. For example, rotation of Earth, the motion of the minute's hand of a clock. The minute's hand always moves at it rotates at the same rate. So if you take its tip, the tip of the minute's hand, it moves at the same rate. Now, some of you may say, sir, it's a ticking clock, so it moves, stops, it moves and stops. Isn't its speed varying? Correct. Its speed is varying. If you consider a clock with like ticks and stops each second or each minute, then yes, its speed is variable. But there are some clocks in which the hands move smoothly. There, in such cases, you can say the tip of the hand is moving in uniform circular motion. It's executing uniform circular motion, you can say. Okay. So you can say like, is or should speed be constant? The answer is no. It's not necessary that for circular motion, the speed has to be constant. In uniform circular motion, it has to be constant. Okay. So you can write it here. Uniform circular motion, answer is yes. Non-uniform circular motion, just a moment. The speed will not be constant. Okay. Right. So this is just a basic introduction to circular motion. Next class, we will discuss like how to find out the time taken by an object to go from one point to another point along the circle, how much acceleration it should have. Okay, radial acceleration is compulsory. How much radial acceleration it should have, in which direction it will be. Okay, we'll also discuss some terms like centripetal acceleration, angular velocity, angular displacement, angular acceleration. Okay, we'll talk about those things. Okay, but as I said, make some effort and solve questions from the worksheet. Tomorrow you will get worksheet based on this riverboat problems. Okay, thank you all. I'm closing this session.